All right, everyone. So let's do some quick review for the derivative of logarithm and exponential function. So as we know, the derivative of e to the power x is actually itself, like ex. And the derivative of eu, the reason why you have the chain rule because the variable that you take with respect to is x, but the exponent is a u. U can be anything. U can be 2x, u can be 3x squared plus 2x, or u can be secant x something, so on. Okay, so you can be anything on the exponent, not just a single x. If you only have just a single x, then there's no chain rule, but this one have a chain rule. Then you're gonna have to have EU times U prime. Okay, and this could be similarly to the a to the power x. A to the power x is the e to the power x is when the base is e. A can be any number. A can be one. No, not one. A can be 4. A can be 2. A can be 1/2, so on. Okay, a can be any number. So when you have the derivative of any number raised to the power x, you're gonna have a to the power x times ln a. And then this, if you have a chain rule, then it means instead of a to the power x, you will have a to the power u. Then you will have a to the power u, but of course, you're going to have to take u prime. And then adding a little bit more, which is ln a. Okay, so this is the derivative of exponent. So let's take a look at some example. So for example, I want to take the derivative of ex squared plus 2x plus 1. Okay, then this is not a single x, so we're gonna have the chain rule. So this problem will have the chain rule, exponential rule, and chain rule. No exponential rule, chain rule. Okay, so how do we apply chain rule? We're gonna have to use this, right? E to the power whatever is gonna the derivative of that will be e to the power of something, and then time the derivative of the power. So you're gonna have e to the power x squared plus 2x plus 1. Okay, this stay the same. This is the derivative of e, and now we're gonna apply chain rule, which is the derivative of the exponent, and that will be 2x plus 2. Okay, so your u here in this case is x squared plus 2x plus 1, and the u prime will be 2x plus 2. So that's the reason why we have EU times u prime. Okay, so that's the derivative of exponent. So if your exponent is something different like trigonometry, so e to the power sine x plus cosine x. We do the same thing, or you have a coefficient. Okay, so if there's a number in front of the e, this is a constant coefficient. When you have a constant coefficient, the numbers stay the same. And then we're gonna take the derivative of e. Derivative of e is stay the same. And time, what is u prime? So u is sine x plus cosine x. Then u prime gonna be derivative of sine will be cosine, and derivative of cosine is negative sine. So we're gonna time cosine x minus sine x. Okay, so that is the exponent. So let's do the exponent that is not e but a. So derivative of a 3a to the power 2x. Okay, oh, not 3a to the power 2x. 3 times 4 to the power 2x. Let me rewrite that. 3 times 4 to the power 2x. So your 2x is applied to the 4. 4 is the base, okay, the base a. 3 is the constant coefficient, so I stay the constant coefficient the same. So this is a to the power 2x, not a single x, so we will have chain rule, chain rule. Then we will have a to the power u, which is 4 to the power 2x stay the same. Now we're gonna take u prime. U prime is your 2x is u. So this is your u, right? So u is 2x, then u prime is 2. So we're gonna time 2, and then time ln a, which is ln of 4. Okay, your a in this case is 4. Your u in this case is 2x. So 3 times a to the power u times u prime, and then times ln a. So this is the derivative of exponent. Okay, so let's do one more. you have 1/2 of uh, 5 3x squared minus 2x. Okay, so this one we do the same thing. We're gonna have to verify which one is the base. The base is 5, so, and the u is 3x squared minus 2x. 1/2 is just a constant coefficient, so stay the same. And then now we have AU. AU is 5 to the power 3x squared minus 2x times u prime. So u is 3x squared minus 2x. U prime is 6x minus 2. So times 6x minus 2. And then times ln of a is 5, right? The base. So ln of 5. And then, of course, after this, it's better that you multiply everything together. I didn't do that, but we should, right? We should multiply 3 and 2, which is 6, ln 4 times 4 to the power 2x. Make sure you put the parentheses so you know the 2x is only applied to the 4. And then similar for the one above, or you can leave it like that, it's fine. And then this one, I'm gonna bring everything to the front, so I will have 1/2 ln 5 times 6x minus 2 times 5 to the power 3x squared minus 2x. Okay, so if you are not get used to with the chain rule process, it's okay to let your u equal to the exponent and then apply the exponential derivative rule and then times u prime. Okay, it's fine.